For today's podcast live session. Let's see. Let's wait for everyone to start joining. So today we're gonna have none other than Aishwarya to share about her career journey because we have a lot to learn, and I'm super excited to have her as a guest at our Technical Founder podcast. And this is a reminder that it is going to be a recording, so whoever is here, make sure to come up with great questions towards the end because we're going to save it as a YouTube podcast session. Yeah, let's welcome Aishwarya. Hi, how are you today?
Thank you, Mary. Thank you so much. Doing good, pretty excited.
That's great. Where are you joining us from?
From the Bay Area, so I stay in Fremont.
That's awesome. Yes, I live in the Bay Area too, but I'm currently in Indonesia. It's like 10 a.m. here. What time is it? It must be 7 p.m.
Yeah, 7 p.m. Yes.
That's awesome. Where are you guys joining? To let us know in the chat so that we can all get to know each other too. But let me share the structure of today's podcast or live session. So today we're gonna have an interview style recording with Aishwarya, and we'll talk a lot about Gen AI and building a career in Gen AI because that's what Aishwarya's main focus is on currently, and most of you are followers of Aishwarya as well. So I cannot wait to learn about your content creation journey and just your career as an applied scientist and also as a lecturer. So when I first saw your profile, I was like, oh my goodness, how many things that you could be doing at the same time. So I'm really curious to know how are you managing all, and yeah, hopefully learn a lot from your journey as well.
Awesome. Yes, looking forward. And I was probably telling you right before we went live that this is probably the first time I'm getting on an interview. I'm not the kind of person who talks a lot. I probably write better, but there's a first time to everything, I guess.
I'm so excited that it's on our show because I think like you have a lot to share. And whenever I read your posts on LinkedIn, it's always about some research paper or some new cutting edge technology. And I'm always just like curious, how are you keeping up with so much research? Because that's almost one of the top questions that we get in our community. So yeah, let's. Why don't we go ahead and dive in? Before, I would like to share a little bit about break into data, and we can get started with the interview. What do you say?
Sounds good. Awesome.
Yep. Oops. Let me just quickly share. So, everyone who joined today, I want to share a little bit about Break Into Data because we share a lot of resources and we host speaker sessions like these on a regular basis. And if you do not know about us, then I urge you to check out our Discord, and you can find it on the LinkedIn page. And you will find things like coding challenges because we do them a couple times a year, and we have real data and AI community where people share about their first jobs or how they're preparing for their interviews. And I feel like you guys can find a lot of value in there. And yeah, we'll host a lot more of these sessions and continue to host these speaker sessions on our platform. And something exciting is coming up, and I did want to share it before we begin with our today's session. Is we're finally launching an exclusive tier for the community. And if you're someone who is searching for a job or is trying to figure out what job fits you the most, and you do not know where to go, because that's how I felt it was very overwhelming, especially during this day. We decided that it's time to bring more value, and we're partnering with other platforms to provide interview resources and give you more accountability meetings that can help you get the job that you are searching for, or that you are currently dreaming of, because the job market is tough, and I feel like the community can provide a lot of value for you. So if you want to join the waitlist, because we have only 50 people for the first round, I urge you to fill out this. I will put it here on the left corner, fill out this form so that you could be one of the first 50 people, because this is our first time launching something like this, and I'm super excited. If you want to be in that group, check out the form and fill it out, so that later on you because later on this community will be an invite only, and we were truly building a network of people that will help each other. So let's go ahead and start our session today. Let's see. Okay. So now that we have most of the people joined, Aishwarya, I'm super excited. I actually, first of all, I really want to get to know your background, because I truly believe someone's upbringing and the family can tell a lot about a child's future. And I was curious, did your parents always like encourage you to do math or statistics or anything like that?
It's funny you ask that because I think most Asian parents are kind of, they have this reputation to ask their kids to work in math and stuff. But no, both of my parents come from a non-technical background. My parents own an educational institution back in India, so
Oh,
there was a lot of emphasis on education per se, but I really did have the flexibility to choose anything that I wanted to. They just wanted to make sure that I make sure that my education is taken care of. And my parents came from a very humble background, I would say. My mom was married when she was probably 18, and I was born when she was 19. And then she was pursuing law at that point. But then I was born, and then she had a bunch of responsibilities. I think she started off. Uh, when I was 2 or 3 years old, that's when she started like running a really small school in our garage, and then that just became big. And now we have a bunch of institutions back in India. So education has been a huge focus, and I have kind of spent a lot of my childhood going along with her to all of these different places where she's teaching and all of that. So still, that is something that I really enjoy, teaching people. So yeah, maybe all of that kind of shaped the career decisions I made as well.
wow, that is so cool. What kind of school was that?
Oh, just like a primary, middle, and high school.
Oh, it's
Yeah.
your home. So she built a school at your home first.
Yeah, she built a preschool at my home. So it was like this really cool nursery for kids. It was supposed to be a daycare, and then it became a school, and then they expanded, and then we had like a full-fledged school. And it was really cool seeing them grow, because their main focus was education at that point. And my dad comes from a humble background as well, but he had a lot of I would say business acumen. So both of them kind of put this thing together. And yeah, I was a part of their journey. So I really appreciate how they, went from 0 to 1.
That is so cool. Do you have siblings too, or you're the only child?
I have siblings. My brother is probably 10 years younger to me. So he's currently doing his undergrad.
Oh wow, I see. That's awesome. Yeah, so it looks like you came from the educational background. I mean, you grew up in that environment. So I was wondering, were there any pivotal moments maybe later on that inspired that curiosity towards data and AI, or when did this like journey begin for you?
I always wanted to do engineering. I just hadn't figured out which space. I wasn't really into computer science, but I just wanted to do engineering because my dad's brother, he was a mechanical engineer. And when I was a kid, I really didn't know what it meant, but he would travel a lot. He would go to places. He would probably go to US, Europe, and at that point, it just felt really cool. I was like, oh, if you did engineering, you can probably travel a lot and then have a lot of fun. And that's how I built that passion. It didn't really stem from anything very logical. Then, as I started growing up, I was like, fine, this sounds like a cool thing to do. And so back in India, when right before you do your undergrad, you have these 2 years where you can kind of decide which field you want to go in by taking a bunch of optional courses, right? And these courses are also kind of very uh, deterministic in the sense that you can either go for computer science or electronics or biology, and this kind of helps you decide what science field you want to take up. And then
Mm,
I ended up taking electronics because I was really afraid of computer science. I thought it's something to do with heavy math, and I was not a huge fan of math at that point. And with the limited information that I had, I thought computer science is a lot of math, so I ended up taking electronics. And I started doing my undergrad as well in electronics and communication. Um, but when I was in my second year, I guess, I met this really cool professor. He works in natural language processing, which
mm,
is essentially, I mean, that's what people would call it before generative AI was a thing, right? The study of language, and basically the science of language is natural language processing. And he had a really good background in machine learning. And that's when I started feeling like, this looks way more interesting than electronics.
mm,
And so I started doing a research project with him. I was really enjoying it way more than my courses, and that's when I decided to kind of pivot. I did not switch my major per se, but then I just started doing projects on the side. I started learning, and maybe my first course was Andrenk's machine learning course on Coursera. Most folks would probably know it if they've been in the space for a bit. And then I started applying to a bunch of internships, and yeah, things just probably started kicking off, I guess. And I figured that this is a space that I want to be in. It's been
mm.
9 years, and I have been working in natural language processing, and yeah, touch wood, things have been going good so far. I think the space also picked up pretty quickly in the past 3, 4 years. So yes.
Yeah, no, I could imagine. This is when I hear somebody say that they've been in the field, especially in NLP, for more than 2 or 3 years. I'm like, yes, we have something to learn before the LLMs came over. But yeah, it seems like you made that pivotal choice early on in your when you were in the second year of college, which is super cool. I imagine back then things were completely different and AI was sort of separate. I mean, the fields within AI were kind of like developing separately, like computer vision from NLP, from everything else. But nowadays, it seems like everything is converging because of the transformers. And I'm curious to hear your perspective of how the evolution has been, and maybe also tie it back to your like how was the career, the first jobs that you got, and how you got there.
Right. I think there has been some form of unification ever since deep learning became a thing, because then you could kind of use similar architectures for a bunch of different domains, right? CNNs were used at some point in language as well, although they didn't perform really well. And LSTMs were used in time series data as well, although it had nothing to do with language, right? So I feel like that unification has been happening for a while now, just that the LLM era has kind of built a lot more momentum than before. Um, what was the other question about?
Yeah,
I
no,
kind of.
I wanted, I guess I asked two questions at the same time because I'm curious, first of all, like, how did you transition to from academic field to the industry, especially like given the NLP, and how was it like back then? What did you guys work on when it was NLP and not LLMs?
Yeah, I have kind of worked with a bunch of different models. When I started off, I think we had a lot of traditional machine learning models, and they were all of these n-gram models, TF-IDF, and things
Hmm.
like that. And then probably in 2017 or 18, when I was getting done with my undergrad, is when deep learning became a thing, and folks were talking about word2vec and BERT and all of these new technologies. And so then I started kind of picking up on neural networks and kind of trying to build them. It was kind of fancy at that point, LSTMs, RNNs, and all of these things. And then when I was in CMU, I think that's when transformers. I did my master's in CMU right after my undergrad, so that's a little context. And I did my master's in Language Technologies Institute, which is specifically it's a lab in the computer science department, which focuses on language technologies. So then I think I saw a lot of real world usage, like transformers were used in a bunch of industries. A lot of your interview questions would also be around transformers, attention. And I took this course in CMU. It's called Intro to Deep Learning or something like that. And we had to kind of code attention from scratch without using any libraries and all of that. And
Cool.
was pretty cool. And we were also fine tuning these BERT models. Again, BERT was a thing back then. It's kind of nice to tell people that, oh, I have fine tuned BERT models and I've played around with them. Because now it's really hard to train LLMs, right? Just because it's expensive. You can fine tune large language models, even as today you can get those 7B models or a little bigger ones. But just building everything from scratch is something that you probably cannot do now. One, because there's so much compute that's required. And then the cost also increases. So I have basically done a bunch of things with BERT as well. And then my first job or my first internship right after my master's was with Amazon Alexa. And even there, I was working on this system where essentially back then the systems were pretty rule based and you had a bunch of different machine learning models to handle different things, right? So if the user was talking about their switch or anything, any of their home appliances, it would get directed to one model. And if they were talking about news and updates, it would get directed to another model. And you kind of had this modular pipeline where you would have this orchestration engine that would kind of direct queries to different models. And I mean, it's kind of fun to think that today one model can do most of those things. You don't really need this orchestration layer at all. And post that, I briefly worked on graph neural networks. So I worked in Alexa for 2 years, then moved to Amazon Search, where we heavily used graph neural networks for recommendation pipelines. And in December 2023, which was pretty much last year, I moved to Generative AI Innovation Center, which is essentially our org that helps AWS clients build generative AI pipelines and put them into production. So yeah, I've kind of done the traditional NLP, moved to transformers and all of these neural nets, and now to generative AI. So I feel like the delta isn't a lot, right? If you've been following what's happening in NLP, for someone to pick up everything that's new, it doesn't take as long as someone who hasn't even been in this space to get started. So also I feel like that is why I don't get overwhelmed with everything that's happening, because I feel that I have a good mind map of all of these different topics. And then every time someone's hyping up something, I know that, okay, this is exactly the new addition that's come up, and it's not going to change everything, or it's not going to kill a bunch of different jobs. There are a bunch of challenges to deal with. So that's how I kind of consume new information, I guess.
That's so interesting. You touched on so many curious subjects actually. Because when you said graph neural networks, that's another interesting subject. And I totally agree. When you have a solid foundation, it's easier to navigate through the noise. But I'm curious. I guess two questions. You can decide which one you want to answer first. But first of all, how would you explain to someone who hasn't worked with graph neural networks? How is that different from regular neural networks? Is it related to maybe graph databases? Because I've been recently also working on a knowledge graph, and that's another project that I'm doing currently. But I'm curious. I have never worked about graph neural networks, especially in the context of recommender systems. So that's the first question. The second one is when you said you have this foundation that allows you to navigate through this like research space that's coming in. I'm curious, what is it that people need to know, especially in NLP? What do you think it's fundamental still is considered fundamental, and what is considered outdated and maybe not necessary to learn for folks that are in school nowadays? Like, for instance, do they still have to learn LSTMs or RNNs or any previous methods that were popular before LLMs? And yeah.
Yeah, about graph neural networks, essentially, I mean, to kind of simply put it, the different thing about graph neural networks is that every node kind of updates its representation by looking at the node that it's connected to, which is not the case in traditional neural networks, right? If you think of LSTMs, you're probably seeing it in a sense that words look at the other words around their context.
Mm-hmm.
It's a similar meaning, but just that you're looking at different graphs in a node, and the relations are not linear. The relations are not just the surrounding words or something like that. It's basically based on the connections in a graph. It doesn't have a lot to do with graph databases itself, although that's a good way of storing graphs so that you can allow graph neural nets to kind of pick up on that information. But essentially, it's pretty simple, right? Think of a social network. If you have one person, then you're kind of updating that person's representation based on all the people that that person's connected to. And connections can mean different things in different platforms. In platforms like Amazon, it might be things like connecting products to people and using this. I mean, the edges could be things like, have they bought a product, have they reviewed a product, or have they taken a look at it, and things like that. And each of these edges can be used to even train that person's representation. And what I was specifically doing is, given all of this shopping graph, which essentially is all of the interactions that buyers and sellers have had, or buyers and products have had, how do you kind of build accurate representation so that you can show buyers the right kind of products that they want to see? And what traditional systems do here is to kind of model it as, you know,
Tower.
uh,
Oh, I was just
sorry.
gonna say, is it two tower the traditional method these days that people?
Yeah, right. A two-tower method, or basically use representations that are flat, but a graph structure allows you to kind of go deeper into their interactions and kind of,
Mm.
give you better recommendations. The more hops you go in the graph, you can explore more. I mean, there's this exploit versus explore kind of
Mm.
phenomenon that you can kind of tweak in a graph neural network. Um, yeah, and graphs are also becoming super important now, right? Because if you're thinking of a retrieval augmented generation pipeline, then the issue with the retrieval part of RAG is just the fact that it's very hard to capture relationships. Let's say you're asking something like, did X publish a book Y? Then did X publish any books, or something like that, right? And if you're chunking out different parts of your data set, and this person X was never referred to in a particular in a particular chunk, just because you've cut down your document into multiple pieces, it's really hard to identify that a particular book was written by X, because X just belongs to another chunk, right? And graph databases might help this, because there's always that relation that's innately stored.
Mm.
Um, so that's why I think a lot of graph neural networks, and also just KGs, knowledge graphs, trying to be a part of this RAG system is also gaining a lot of momentum, because most of enterprise data, I mean, you can put a lot of enterprise data into a knowledge graph, and there's already some amount of indexing that is done at the enterprise level, and folks can use that instead of just using semantic similarity, which is more of an LLM thing.
Mm. I love that you are touching making the connection between the LLMs and the RAG and graphs, because that's exactly what I'm teaching on my upcoming course with Data Camp. It's a RAG with the graphs, and like,
Oh, super cool.
yeah, and I that's exactly actually that's exactly what you said, because it is hard to retrieve relevant data from the large corpus of the documents. The graphs can like really represent the relationships the best, and I think that's exciting. I'm excited about the graph neural networks too, because I have never worked with them, but that sounds. I love how we just dived into the topics like the nerds we are. But I did want to get to know more about your work these days as well. So you said that you worked with Alexa when you first joined. And I'm curious, maybe you could share some of the evolution, or however much you can share the evolution of, like you said before, it was a lot of different orchestrations and different methods, and maybe one, how do you call it, assembly line, or how did that change later on? Did you when the especially when the LLMs were became popular? Did the corporations were like, oh my gosh, okay, now we have to move Ashwarya to Gen AI?
No, I made that choice. I think there are a ton of smart people in Alexa who can kind of take the lead. But um, definitely, I would assume, like, I moved out of Alexa even before LLMs became a thing. I was working with graph neural nets, so I don't have first-hand information, but I feel like most corporations obviously have a lot of pressure now that LLMs are able to do a bunch of different tasks, and you don't really have to have this complex orchestration pipeline because you have this one foundation model that can do a lot, right? But again, I feel like in legacy systems or in systems that have been around for a bunch of years, there is a lot of workflow and a lot of um, a lot of processes that have already been set up, and you really need to kind of rethink the design when something like this happens, right? And you can't really change things overnight because these are products that are already in front of customers. And just the fact that if you've been using Alexa for a while, you kind of know how it behaves, and you don't want massive changes to happen overnight because you've set up some routines, you've set up some kind of interaction pattern with systems like these, right? So I feel like it's less of science and more of trying to understand the design, trying to understand your customers, and kind of it's more of a product kind of a decision to make as to where you want to make those changes and kind of iterate and make sure that the customer doesn't feel like it's a shock for them. But yeah, I'm sure Amazon's been doing a bunch of different things with Alexa as well. And yeah, we have seen a bunch of new updates, and the momentum will probably keep going on, I guess.
Mm. Yeah, I think the question that I mean, as previously, I'm curious about that one too, about the NLP these days. What do you think people should learn? What are the fundamentals that are more relevant these days, and maybe some of the historical things that people do not have to learn as much?
Yeah, I think that's kind of a subjective question. Everybody kind of has different answers to this. And I would say it's okay to not really learn too much about traditional NLP stuff before, say, RNNs or LSTMs, because that amount of background is really enough for you to get started with systems as of today. And I'm also someone who's very application driven, which means what problem are you trying to solve, get started with that, and then learn the technology that you need in order to solve that problem, right? But that's also
Mm,
because I come from a very applied science kind of background. But if you probably talk to someone who's into research, they'll probably be a little more they probably emphasize more on knowing the foundations, because if you really need to publish something groundbreaking, it has to be grounded by a lot of foundational research, and just starting off somewhere from the middle might not be really helpful, right? But I'm someone who kind of wants to take a problem, think about solving it, and then learn the technology that's associated with it. So I
mm,
would say you wouldn't have to learn things. I mean, upfront, you don't need to know anything more than RNNs, LSTMs, transformers, or just
mm,
some good understanding of how word to vec works, or like embeddings work and things like that, right?
mm,
Um, there are more traditional NLP methods. Like I was saying, there are a bunch of bigram, trigram models that people would use previously, naive based to do these things. And I think it's okay to skip it and kind of come back when you feel like you hit a roadblock. But at
mm,
least the beginning of neural networks and how neural networks can be used in natural language processing is a great place to start with, I guess.
mm. I see. I wonder how, like back in the time when you said you first joined Alexa team, how was the job search back then? How was the job market? And what were the questions like, or your preparation like, or did you have any other companies that you had in mind? Just curious to know how it's different from now.
It was definitely an employee market back then, which means that companies were actually hiring like crazy. I graduated from CMU in 2020, 2020, yes. So it's probably been a while. And kind of one of my biggest, I mean, not regrets, I guess. So I had offers from Apple, Nvidia, and Amazon. I went for Amazon, and Nvidia stocks have skyrocketed since. But I really wanted to work with this team in Amazon because it was Alexa and it was really cool. I'd interned with them. I had a really good rapport with the team. So I just decided. But yeah, back then, most companies do this, right? There is an ML, obviously, there's some amount of coding that's required for even ML engineers. There's lead code and all of this. But if you're applying for a machine learning role, there's lesser emphasis on lead code, which means that one, you will probably not be getting really difficult questions that a software engineer at the same level would get because your emphasis is about knowing machine learning. And then there are a few interviews around machine learning depth, which has to do with your specialization. Like if you've done a bunch of projects in natural language processing, they'll probably dig deeper into it, kind of grill you around those things. And there are questions around machine learning breadth, which is pretty much, do you know a bunch of algorithms? Do you know how gradient descent works? Stuff like that. Yeah, dropout, batch norm, these were the kind of things that would get asked. And I think that's pretty much what folks would ask even today in terms of ML breadth.
Yeah.
And then there's also ML system design, which is given a business problem, are you able to design a solution, come up with some kind of an architecture, identify how to scale it, how to drive business metrics, and stuff like that. So
Hmm.
I think there's like 5 or 6 interviews, and pretty much these are the things, I guess. I'm not a huge fan of lead code, and it's nice that machine learning roles don't really have like super hard lead code questions.
Hmm. Yeah, thank you for sharing. I also, when I was looking at your profile, I saw that you co-authored so many research papers. I did want to ask you, how did you find the co-authors or the topics to research on? And did you think that was important in your career as well?
It was definitely super important for my master's, I would say. I started doing research with this professor of mine, right? That from undergrad, and then I started just going out for internships, and then most of my internships back in undergrad were research internships, which means that the deliverable is a research paper at the end of the internship.
Mm.
So it's kind of part of the program to write something. Um, and yeah, the thing about masters, so I come from an electronics and communication background, and for me, by my standards, I thought I wouldn't get into Carnegie Mellon because it's one of the top CS programs there. But I had a bunch of research papers, and I think that they really helped because it would help
Mm.
show whoever the reviewing community is that I have some experience writing a bunch of these papers, performing some research, implementing these things. And I think it really helped, especially because I came from a electronics background, and in order to kind of convince someone to have you go to a good CS program, you really need to show some form of experience. That could come either in terms of internships or publications. So those publications really helped. And post that, I think when I started working, I wanted to continue to do research just because it helps me keep updated with everything that's happening in the space. When you start working in the industry, everything that you learn is kind of focused on the product that you're trying to build, right? Which is really cool, but then you kind of lose touch on the latest things that are happening in a space. And academia is the place to be if you really need to understand the state of the art things. And just attending these meetings and kind of listening to research paper readings and contributing to it, I feel like has been super important for me, even in the past 2 3 years, where there's so much that has happened in
Mhm.
generative AI. And then I collaborate with a bunch of professors, so we have these LinkedIn groups where we're constantly sharing papers and saying, oh, this happened, we should probably do this, I mean, talk about this in our next paper reading and stuff. So it's just my source of information and my way of keeping updated. And most of the papers that I post on LinkedIn as well is basically the best ones that I've picked from our discussions, the ones that I think would be really useful for my audience.
Mm. Oh, it's interesting. I love the transition that you made to the content that you create these days. You mentioned the LinkedIn group. Like, is this like your private group with your professors from Carnegie?
Yeah.
Oh.
No, these are not professors from Carnegie Mellon. So these are from a bunch of different places. I was collaborating with folks from Stanford last year, and then I also collaborate with my undergrad professor, who's currently at University of South Carolina right now. So these are essentially a bunch of PhD students, a bunch of advisors and professors who are I mean, the end target is to publish a paper, and we all collaborate and kind of brainstorm to kind of work on this and kind of come up with a final product. And most of the times, I mean, research itself has changed so much in the past 2 3 years. Kind of
Mm.
off topic, but previously, if you had to write a research paper, you could kind of take your own sweet time. And by own sweet time, I mean you could take 2 3 months to kind of identify what you really want to work on, do your literature survey, come up with some baseline experiments and stuff. But over the past 1 year, turns out that we start working on some paper, we have some good results, and by the time we start writing the paper, someone's already published something and they have results better than us, and you kind of got, you need to go back to the whiteboard and figure out why someone's performed better. And basically, there is nothing novel in your paper, there's no point writing it, so it takes a lot longer to publish something. So
Mm.
yeah, a little bit of a rant, I guess.
Interesting. I guess it's also a lot more competitive then these days.
It is a lot more competitive, but I think the noise is also significantly increased. A lot of papers coming up, and most of them don't really add a huge value to existing research. And there's this new trend in the language space, which is a lot of people just upload their papers on archive, right? They don't, because it's previously what you would do is if you're writing a good paper, you would upload it on archive, yes, but you would also try to submit it to leading conferences, and that's when you would get a lot of visibility. But these days, people don't have time to wait for a conference deadline, because by then someone's already working on it, someone's already trying to publish something, and so you just put it on archive, you just use your network to kind of gain visibility and things like that.
Mhm.
And now you don't really need to back up your research paper and say that it has been accepted at so and so conference. You can literally just go up on LinkedIn or one of these social media platforms and say, oh, you know what, I beat OpenAI on this particular task, and we really have this cool new paper, and everybody will start looking at it. I feel it's a good thing and a bad thing. Is a double-edged sword. People are getting a lot of visibility even without going through this conference process. But at the same time, there's a lot of noise to deal with. Like, there are these fancy titles that everybody's coming up with. Everybody wants to kind of portray as though they're doing this research that is going to change everything. So it's really hard to kind of review these papers and decide what is actually bringing good value and what is just, research paper for the heck of it.
Mm, interesting. I did not know that. But yeah, I wonder if we can also take in some questions from the audience. I know I think I've seen some questions over the past few minutes. Let's see. So Leo is asking, do you think the AI engineer role falls closer to the traditional data sciences or the traditional software engineering? Yeah, what do you think about AI engineering? Since you mentioned there's so many new roles, do you mean like AI engineering as well, or are there anything else? And what do you think about AI engineering too?
Yeah. I don't know. I just feel like AI engineer as a role will quickly transition to a traditional SWE. I think Leo's question was also kind
Oh.
of getting at that. Because uh, think of it, right? We're moving into this paradigm where most software systems will use some form of AI. I think Andre
Mm,
Karpathy came up with this term called Software 3.0, which is essentially the way you code, the way you program will also be significantly changed by AI. Maybe you would probably not have to write all the code yourself. You would augment AI to it. And even in your software pipelines, there would be AI systems making decisions and all of that, right? So
mm,
I feel like every software engineer will have to use AI tools at some point. And this term of AI engineer is, I think, short lived because over time, most software engineers will also become AI engineers. And it will be really important for them to pick up all of these tools and platforms um, that I mean things like LangChain and stuff, but I think we'll have more mature products over time. And I don't know, I just feel like the role will quickly move into a traditional software engineering role. And a lot of software engineers who are kind of oblivious to AI will will have to start using AI anyway.
mm. Interesting, because I thought AI engineering is like a perfect transition for someone who wants to work with LLMs or wants to implement them in the production environment. But what do you think then is the natural progression, or what is the role that would be responsible for implementing Gen AI, or what do you think about the titles and the naming and the skill set that's required these days in the production, since you are working in the production environment?
So, one thing, right, is that there are very few people, at least as of today, who are training models. Um, First of all, there are very few companies that are doing it. And then, even in these companies, let's say folks at Meta who are working on llama models, there are probably hundreds of folks in these research papers, and everybody's not training a model. There are people who are kind of making sure that the data is clean. There are people who are, um, making sure that the prompt engineering piece works fine. Some people are working on post training, and there's this huge pipeline that's required even just to train a model. So I don't think everybody will be training models or everybody will require a lot of information to train models sometime in the future, right? You can treat LLMs as this black box where you provide some inputs and expected outputs, and you would have, fully mature and managed services in order to do the training for you, which means there's a lot of work that can be done in the application layer. Now, where ML engineers or I feel like the traditional data scientist role is also very, I mean, it's an umbrella term for a bunch of different things, depending on what team and what company you're working for. If you really think of it, applied science is kind of a sub discipline of data science, where the emphasis is more on model building, understanding what truly goes into the model and kind of connecting that to business metrics. Um, but yeah, I feel like maybe machine learning engineers will probably do some, I mean, there'll be more emphasis on the model itself, but then there'll be a higher degree, or I would say a traditional software engineer will be using these AI models at the application layer, and they can pretty much assume that these LLMs are black boxes and not really know too much about training them, about fine tuning them, etc. And machine learning engineers will have that expertise, which is given that something goes wrong in the pipeline, or if you have a bunch of logs and you're kind of monitoring how these responses are, how these LLM responses are being generated, they should be able to understand um, how these models are built and how they function and things like that, right? But I just think that software engineers in any different field will have to kind of start using AI to some extent.
Mm, I see. So I guess what I got from this is that there's not that many people that are pre-training their models from scratch, which makes total sense because pre-training one from scratch costs around $1 or $2 million, and not that many people can afford that. But Application layer is interesting because then people get into this field of like we have so many thousands of like open source models that are hosted on Hugging Face, and then you have to just know which one is perfect for your use case, and then fine tune it, and then maybe build a RAG around it. And I think is that what you mean by the application layer?
Yes, pretty much. Yeah, yeah.
Yeah, I think that's an interesting field in itself, and I think it's booming too. Yeah.
Yeah. Yeah, yeah. Honestly, I don't even understand why there is an ML engineer and an AI engineer, because you're pretty much talking about ML engineers. I don't see the difference between AI and ML. I mean, ML is a subdiscipline of AI. I don't know what an AI engineer would do differently than a machine learning engineer, but I
Mm,
think this is a field that's moving so quickly, and everybody wants to kind of introduce new terms and kind of bring up new definitions, and whatever I'm saying today might not be true tomorrow. So yeah, probably we'll have to take all of that with a pinch of salt, I guess.
mm. Yeah, but at the same time, I still like to like capture these moments of like the assumptions that we're making now, just to see what how it's going to change in the future. So I'm curious though. But what about, let's get back to your role as applied science, because only recently I found out what applied scientists do, and I feel like that's very exciting. I think you might know Daliana is also, we're here in Bali together, and she's also an
Wow.
applied. She used to be an applied scientist as well, and she explained me that it's basically when you take on a project from external customers of Amazon, and they give you a problem, and you have to come up with a solution within like 6 months, and like give them a production version. And I'm like, wow, that's intense. And I feel like that's also a very interesting field to be in, because at the same time, you're at the intersection of like cutting edge research and industry. And I feel like that's just a beautiful space. But what do you think? And what are you working on as an applied scientist? How does it look like for you?
Yeah, again, the definition is kind of pretty different in different orgs and different teams. But how I see it is, most of these large corporations have research scientists who are basically people working on the long-term vision of the company. They don't really have to do things that customers want at this point. They can kind of do, fancy things, try out new models, and you're not really measuring any metrics. And on the other side, there are machine learning engineers who have to productionize machine learning pipelines. They should do monitoring, logging, build the infrastructure around it. And applied scientists kind of are the bridge between these two roles, right? Which is, you understand research very well, and then you also know what it takes to go into production. You also know what customer metrics must be optimized, and you kind of ha- you kind of have the best of both worlds and kind of put them together to build solutions for customers. That's how I see it, or that's how it is scoped in most companies, at least FANG companies. But yeah, I think if you like speak to a bunch of different people from different teams, they'd come up with different definitions. But on the high level, that's pretty much what it is, right? You're someone who has deep subject matter expertise in a particular science field. It can either be natural language processing, computer vision, or one of these things or more. And you're also able to map business goals to scientific problems. And then you can also map business metrics to scientific metrics. And you kind of get all of this overwhelming research from research scientists, figure out what is important to the customer, and kind of package it for the machine learning engineers to then take and scale it and kind of build pipelines around it.
I see. If you can share, what are the type of projects, or give us examples so that we have a better idea of like how it looks like, or what have you done too as an applied scientist?
Sure. So again, like currently, I work in an org called Generative AI Innovation Center, and what we do is, Amazon has a bunch of generative AI services. Like, it's called Bedrock. It's a platform where you can build generative AI applications, and we partner with AWS clients. These are ISVs, mid-sized companies, software technology companies, And we use Bedrock in order to build AI applications for them, right? And we either build them in-house, or we also provide an advisory kind of a setting where you help their data scientists, their machine learning engineers to kind of onboard to this technology and build their pipelines. And the most challenging part here is just the fact that these customers come to us with a business problem, and it's really the applied scientist's skill to identify if one, this problem can be solved using generative AI, if it has the right fit, and two, if
Mm,
you're solving with generative AI, how do you kind of monitor if it's making money, or increasing productivity, or what are the impact metrics that you should be looking at. And once you have that design in place, you kind of go ahead and implement it. And also, a huge part of my daily job is to do these three things, right? Like design solutions, guide a bunch of applied scientists, solution architects, and machine learning engineers to implement it, and also communicate your results to these stakeholders. Like we have generally we work with practitioners, but there are also C-suite folks who come on these calls, and kind of they want to understand how their business metrics are getting better. And um, so communication is also an important part of my job, at least the org that I work for, because you really need to be able to translate your wins to different sections or different kinds of people and let them know how this technology can be useful for them. So that's pretty much what we do. We take on these engagements and we design, implement, and
mm,
productionize generative AI applications.
mm. That's so cool, actually, because I feel like, especially in your field, I can imagine the amount of demand there is for Gen AI solutions. Did you notice that spike recently, or how has it been for your department?
Yeah, so I moved to this org in 2023 December, and it has been crazy ever since. So I think we're still in that phase where a lot of companies want to incorporate generative AI in their workflows. Also, there are times when you really need to tell these leaders that you probably don't need generative AI for this. You can probably use traditional AI. So there's a lot of hype, and a lot of companies also have this notion that generative AI can magically solve some use cases. So a huge part is also trying to scope problems for them and making sure that we're giving them, the most cost optimal and performance optimal solutions, rather than just pushing generative AI everywhere, I guess.
I see. Yeah, let's talk about the generative AI trends these days, because you're in the middle of it. What do you think about the trend towards agents? I noticed that there was a big popularity around like RAG last year and this year still, and then I feel like the new trend is coming up is like AI agents. And do you have customers that are inquiring about these tools, or what do you think about agents?
For one, I think I've told a bunch of people that I've spoken to over the past few months that agents aren't a new technology. They're just an engineering innovation. At least at this point, they're an engineering innovation that's built on top of LLMs, right? When you give LLMs access to a bunch of tools, when you kind of prompt them to plan and do a bunch of, and basically perform actions because you've connected them through engineering components, that's pretty much what agents are, at least at this point. At some point, we want agents to evolve to kind of get information and kind of train themselves to perform tasks better, but we're still not at that point. Um, I definitely feel there is a lot of scope in terms of what agents can do. But again, their performance is upper bounded by LLMs themselves, because if an LLM cannot do something, I mean, think of it like the LLM is the brain for the agent. If the capabilities of the LLM do not allow you to do something, then you're probably not going to achieve anything by having an agentic framework around it. I have seen a lot of success with tool usage specifically, which is, let's say you have a bunch of tools and you want to kind of make this routing decision on which tools to use, and you also want to kind of get those responses and do this back and forth between LLMs. You could implement it without an agentic framework as well, but then it's just less clunky to have introduce an agent. So tool usage is something that I've seen a lot of luck with. A lot of enterprises are also using it, planning and tool usage. But something that I still think, I mean, I personally think hasn't been super successful is multi-agent systems, because they're super expensive. And when you allow a bunch of, LLMs or say agents communicate with each other, the errors can ripple. It can lead to collusions. And there is a lot of research on how to solve these things, but we're not there yet in terms of just deploying these multi-agent systems in enterprises.
Mm, interesting. And I guess just a single agent will not be good enough for any company. That's why agents are not as deployed these days.
You can do a lot with single agents as well. People kind of underestimate how much you can achieve with single agents, because again, there is a lot that you can do with just the engineering itself. um, think of this, right? If you're a company that has a huge set of databases which are probably structured, let's say MySQL databases, and you also have some documents and all of this, and you want to build a chatbot, you can
Mhm.
literally do it with a single agent, right? The agent just has to decide what is the knowledge source and kind of get that information, summarize it for you, and kind of give you an answer. And probably you'll have access to tools which can generate SQL queries based on the questions you're asking. And
Mhm.
if the question you're asking is from a Word document, it can kind of pull that up and stuff like that, right? So a lot of use cases can be solved with single agents. And again, like I said, I feel the most useful part of having agents is just this access to tools and kind of doing this
Mhm.
orchestration and planning. Um, yeah, there have been a bunch of successful real world use cases of single agents, as long as you have well documented workflows and you kind of have non ambiguous tasks.
Mhm.
Um, but the goal for agents at some point is to be a little more autonomous, which means that given a new task, a novel task that hasn't been done before, they should kind of figure out how to do it. But at this point, I feel like the LLM capabilities kind of limit them to do that.
Mhm. Yeah, that's I think that's very interesting because we're entering this new world of like there are so many possibilities of what AI can do, and we're just scratching the surface of it. At least that's what I think. And especially when Notebook LM, for instance, came out, I was like, wow, I thought we already like surprised everyone with what AI can do, but I realized afterwards that there's so many applications that we haven't even deployed yet. What do you think is what do you find exciting in this Gen AI field, or where do you see the most opportunity?
Right. I kind of have mixed opinions about Notebook LLM. I Notebook LM, I think they packaged it really well, right? It was a great product because people could just upload things and kind of listen to it. I tried it with a bunch of different articles, and it's a hit or miss, but I really think there is a lot that you can do at the application layer again, right? You can take these LLMs and kind of build these prototypes, or you can build these products that are really appealing. But what I'm also super excited about is how well these systems can be used outside technology, right? Like folks like us who've been in the software industry, there a lot of technology kind of gets implemented pretty quickly. But there are a bunch of different domains, let's say legal or biotechnology and financial companies who haven't used a lot of AI until now, but then just because there's so much hype, they kind of want to understand how AI can automate things that they've traditionally been doing. And like Harvey is an example, right? It's a startup that does legal AI, and it's pretty cool how LLMs can really understand legal lingo and kind of augment with lawyers and attorneys. So I think there's a lot of potential outside the software and technology space, because um, things not been streamlined yet, and I think AI can kind of help augment and kind of reduce repetitive tasks. And just the fact that it's a space that I don't really know, and every time I interact with someone outside, the software space, like folks who are working in these domains where very little automation is there at this point, just to learn and understand how AI has been helping them is pretty exciting, because these are kind of the low hanging fruits, because you can literally just go and use existing models, build RAG systems, and it reduces so much effort for these industries.
Mm, interesting. For some reason, I thought, or maybe it's just the environment that I'm in, that everyone has RAG systems already, like every non software company. I don't know if that's, but you're saying it's just the beginning.
Exactly. That's the thing, right? We are so surrounded with folks who have a similar background like us, or who are in a very similar industry, and we end up thinking that, oh, don't you know what RAG means? Everybody knows about it. But then you kind of step out and you figure out that there are industries that are even a little hesitant to use this technology at this point, and especially the ones that are not directly related to software, right? And um, uh, honestly, like, I've been talking to a bunch of different startups who are working in this space, and it's really exciting, the amount of potential that's there in these industries. And no, they do not use RAG systems even as of today, and you will be surprised to know a lot of them are still sticking to very basic processes. And even, let's say they have a bunch of different documents, they don't have a good search mechanism.
Mm.
um, I feel like at least there's so much hype about AI that the leaders in these companies, the decision makers, are actually, trying to see if they can incorporate AI, because everybody's talking about it, I guess. The hype is
Mm.
doing some good.
Interesting. I was like, wow, I probably need to get out of my bubble a lot more. But yeah, let's take another question. Kashtub is asking, what should be the steps moving forward in Gen AI skill learning? Where do you start and what do you learn and from where? So basically, if somebody wants to break into Gen AI, get their first job, what do you think? What they should learn?
Again, like, just the fact that generative AI is becoming so pervasive, there are a bunch of different roles that you can work in, right? You can work at the application layer, in which case you should be really understanding how to apply LLMs to real world business use cases, right? In which case you should really understand what are the usage paradigms. If you really think of it, there are only at this point 3 or 4 different ways of using LLMs, right? One is just to do prompt engineering, where you're not really doing anything with the LLM, you're asking it for answers. And the second level is when you go for RAG, where you augment some knowledge and kind of make sure that it has enough context to answer your questions. The third level is probably allowing it access to tools, which are agents. And the fourth one is modifying the model itself, which is fine tuning. Now, if you understand that these are the different usage paradigms, and you also understand the challenges that come with each of these paradigms, you pretty much have your foundation there. Like, just do courses around these things. Start off with prompt engineering, then understand what RAG is, then agents and fine tuning. You should pretty much have a very solid foundation. Again, I probably say this all the time. When I say do a course, doesn't mean just keep listening to a bunch of different tutorials and don't really do stuff hands-on. I think you need to do courses where you're really coding, you're trying to build projects, you're trying to use these LLMs and kind of spend the time building stuff. And once you have that foundation, I think it's really easy for you to build on top of it. It doesn't really matter if you're using LangChain or Llama Index or Bedrock, because you really know that these are the usage paradigms and these are the kind of problems that I want to solve with it, and you'll kind of pick up everything that's going to come up and not be really overwhelmed by it.
Mm, that's a great advice. Always stick to fundamentals and not tools. But I am curious, though we haven't touched this one subject, and I think we'll transition towards a Q&A section. So, guys, whoever's listening here, prepare your questions. We're going to start Q&A soon. But Ashwarya, what made you start content creation? Because I assume it's a completely different lifestyle and just way of thinking. And I'm curious, how did this journey begin for you?
Yeah, I think back in January when generative AI was, super hyped up. I saw a bunch of different people without a lot of knowledge kind of throwing in information. And also just because ChatGPT was public at that point, people would just write I mean, pretty much a lot of crappy information. And I would keep complaining about it, right? I would read these things on LinkedIn and I would go back to my husband and like, these guys don't know anything. Why are they writing? And they're creating hype and stuff. And I mean, we were just having this casual conversation, and he said, I mean, why don't you try writing? I know that you really love writing. So just
Yeah.
try to do it. Maybe instead of just complaining, might as well try your hand at writing. And at that point, I also moved. So I started writing in Jan this year, and I had really moved to my new team. And generative AI was also new to me. The
Mm,
fundamentals remain the same, but there's so many new technologies that I had to pick up pretty quickly when I moved to this new org, right? And it was also just a way for me to keep updated. When I published my very first course, which is Applied LLMs Mastery, I think it's on GitHub now. I was learning along the way. So I was kind of writing content, I was learning, I was kind of getting it reviewed by folks who knew more about the space than me, so that it was kind of vetted information, right? So that's how I
mm,
started writing, and then just figured out that people enjoy what I write. And then once I
mm.
kind of picked up on all of that information, I was reading a lot of papers, and I started writing about those papers as well. Again, I didn't know that LinkedIn would be a place where people would read papers and be engaged. I just felt like I had seen a lot of influencers write too much about, jobs or their employers and things like that. So I just started writing without even expecting that people would look at it and even feel like it's something valuable. But then, yeah, I just kind of picked up, and that's how I landed. My lecturer role as well as Oxford. So my repository
Mm,
was used for one of their courses, and they reached out to me and said, "Do you want to just probably provide guest lectures as well?"
mm,
Um, so yeah, so I just felt like it was good amount of visibility, and then it was also keeping me very motivated to continuously keep reading and kind of keep myself updated. So that's yeah, that's pretty much how I got into it and how it's going.
that is so cool. Yeah, and we didn't even talk about your repo. Congratulations on so many stars. You must feel very proud because I think that's like just like follower count on LinkedIn, stars on GitHub is also something that people want to see, want to have. But how was? I guess you created the course there, and you did. That's where you started sharing your learnings. And was it complementary to your LinkedIn, or was it something that you just wanted to have as a, I don't know, portfolio piece, or how was it created?
Yeah, it was just that when I was publishing content from my course, LinkedIn obviously has a very bad indexing algorithm, right? If I'm publishing something from week 2, then folks have to kind of go through my feed and find week 1 and stuff like that. And
Yeah.
initially, the course content was on Notion. I had like a Notion website published. So I just wanted a better way to index all of that information. Someone could just open it and kind of see all the content at once. And I kind of transitioned from Notion because I found that it's not very discoverable when you search for my course name, just because it was a website without any traffic, right? Without too much traffic. So it wasn't like popping up in the search
Mm,
results. I wanted a higher discoverability, and that would probably, I mean, it would probably be better if I had GitHub. And just the fact that having a public repository allows folks to contribute to it. If someone
mm,
finds there's an issue with something, they can probably open a pull request. If they have access to new resources, they can probably. So that there's a lot of collaboration that you can do as well. So again, didn't plan anything. I created the repository just for the course, and then over time I just got ideas and started populating it, changing the structure.
mm. That is so cool. I always love learning about the beginnings and the way it has transformed. And yes, where some people are saying thank you for your husband, for making you start writing content, because truly, I think you're one of the only people that I follow that consistently puts out the research papers and helps people digest the new information. So you're doing amazing work. So thank you for that. And I guess this is my last question before we dive into the Q&A section. Looking back on your own career, what's the one piece of advice that you wish you had received earlier?
This kind of has nothing to do with AI, but I feel no matter what career you pick, there's so much of people skills that you need to learn and so much of communication that you need to learn in order to be successful. The most successful people that I have seen are the ones who can communicate really well, who can really understand where people are coming from. And I feel like as people in technology, as folks who are like software engineers or any role in a software company, we focus too much on the technology itself and kind of making sure that you know everything about it. But then,
Mhm.
as you kind of spend more time in the industry, you realize that people skills are as important, communication is as important. So maybe some amount of priority to that would have been good. I could have picked up on those skills much sooner, I guess. Yeah, and just the fact that most people that I talk to who probably come up to me and say that this is really impressive, you've been writing and getting a lot of visibility. I feel like when I kind of turn tables and say, okay, why don't you start writing as well if you feel like this is something this is a position where you want to be in. I feel like a lot of people are too concerned about their reputation. Like I've heard a bunch of people say, what are my coworkers going to think, and what are
Mhm.
my friends going to think. I just feel like you constantly need to put yourself in places where you you're probably starting off afresh. You take up experiences that maybe humble you, and that's the only way to grow. And we think too much about our reputation. Even when I started writing, I work with a bunch of super smart folks, and I thought, who would even read my content, right? Because
Mm.
all of the folks that I was connected to at that point were probably as smart or much smarter than me. But over time, I just realized that most of us stay in a bubble and we really don't know what's out there until we go out and explore and kind of start figuring things out. So maybe just the fact that don't take yourself too seriously and probably try new things, I guess.
I love that. Love this. This is a great ending for the podcast recording. But now let's dive into the Q&A section. Thank you guys for listening so far and learning alongside me about Aishwarya's career and her lessons. So let's ask questions now. Put them in the chat, and we'll go from there. Kashtub is asking, how do you get ideas on what do you write? That's an interesting question.
At least in I think Mary's content is a lot more creative than mine because I have a very clear agenda of what I want to write, right? I read one paper every day. I wake up in the morning and I
Wow.
kind of decide on what paper to read, and I'm writing about that paper. So
Mm,
it's kind of a very streamlined process at this point. Like I just wake up, read a paper, and then if there is a particular topic that's being really hyped up, I want to make sure that I write a one-on-one guide on it because I feel like social media platforms should have more educators and not influencers. Instead of saying that agents will
mhm,
change everything, just write a one-on-one guide and allow people to decide for themselves when they
mm,
understand what that technology is. So that's one way I write content as well. Everybody was talking about agentic RAG at some point, so I just wrote a guide on that. And apart from that, research papers, pretty much whatever I read, I kind of try to choose the best ones and write something about it.
mm. I love that. Yes, I was thinking the other day too. It's probably a good idea to have some type of like structure when you create content because for me, I just write whatever comes to my mind at that time. And sometimes it gets hard.
Yeah, I kind of wonder sometimes how you come up with these ideas because each of your posts is very different. I feel like I can never come up with all of those ideas. And just waking up every morning and feeling like, oh, what should I be writing about today is really hard. So I don't know. My niche is kind of way easier than what you do, I guess.
Yeah, I think that's my part of ADHD that seeks novelty every day. Um, Great. Let's see. What should be? So I've seen this question a lot. I'm curious. Also, what would be the roadmap for AI architect? I haven't heard about this role before. Is there such a thing, even AI architect?
So I don't know if I'm kind of getting at the same thing, but there are solution architects, right? Which who are essentially people who understand an external business's architecture really well, and they also understand the available generative AI technologies, and they kind of act as integration points, like they identify how you can integrate generative AI into existing pipelines, right? But they don't really go very deep into the implementation parts of it. They're more like technical advisors when building these pipelines. Um, and I would say the roadmap is pretty much the same. It's just that how much time are you spending on implementation versus on designing? If you're an applied scientist, you probably spend a lot of time on the implementation and communication rather than the designing aspect. But solution architects spend a lot of their time doing the design and also communicate all of that to the stakeholders, I guess. So there's lesser emphasis on implementation if you're an architect. But
Mm.
I would say it's pretty much the same things. You should know all of these technologies, and they should know a lot more about operationalizing as well, because um, customers or companies who want to build generative AI pipelines are most of the times not very concerned about performance, because a bunch of state of the art models give you the similar level performance. They're concerned about latency, they're concerned about cost, they're concerned about ethics, they're concerned about the guardrails that go into it, security practices, and things like that. And it would be really useful for architects to kind of know all of that information and make sure they communicate it.
Mm, interesting. Yeah, so many people focus on the technical sides of LLMs instead of like regular business metrics that everyone cares about. So this is great. I hope this is eye-opening for many. But what kind of projects should we do to stand out? And some people are asking also to transition from other fields. What do you think? How should one prepare their portfolio?
First of all, I feel like a lot of people need to start using these LLMs really heavily. A lot of us are kind of very hell bent on, oh, what is a project? Give me like a project description to implement. Most of the times, you don't need it. If you're using, let's say you're referring to a bunch of papers on an everyday basis, can you build a rack pipeline around it and see how it works, right? And let's say you're someone who's probably a data analyst and you're writing SQL queries every day. Can you see if LLMs can do that better? Anything, right, that has to do with knowledge work, if you can sit down and think how do you want to automate it and how you can build a pipeline around it, you're actually solving a real pain point. There are a bunch of projects you can do online which are stuff like this, but then I feel like when you build something that solves your own pain point, you really understand the challenges that come with the technology. You understand what are the places where it should get better and stuff like that, right? Like I mentioned, the usage paradigms for LLMs are prompt engineering, RAG, agents, and fine tuning. And with these four paradigms, you can build millions of applications and think about the application that makes you feel happy. Like if you automate that part of your life, would you really feel good about it and maybe do those kind of projects? I feel like they're more specific to you and they're unique to you.
I love that. Yes, I feel like whenever you're doing or building something that you're passionate about, you're likely to get through the end and actually make like impact in whatever you're doing. This is great. And there's some questions about degrees. What do you think? Should one get a master's degree to break into Gen AI?
Again, it depends on the role. Let's say you want to become an AI scientist, right? Or even an applied scientist. Personally, I think I had very good foundations because I had a degree. Most of the deep learning knowledge that I got was from my Carnegie Mellon degree, and I don't regret a bit spending so much on that degree. And I personally felt that the community was also really important. I was working with a bunch of people who are pretty smart, that kind of makes you want to achieve more as well. Maybe the same quality of courses are available outside, but when you kind of work with a group of people who have different perspectives, who come from different backgrounds, it really widens your perspective about the world as well. That's pretty much why I love degrees. But just in terms of education, I feel like you can kind of get all of that education outside a degree. But given how much content is being generated, how much is being created these days, it's also hard to navigate through that noise. And if you
Mm,
really do get a degree, it's structured well for you. So you end up, not having to spend a lot of time understanding what or where to learn from, because that is pretty much done for you already. But again, I think it's a personal preference. I would prefer having a degree if you wanted to become an applied scientist or something like that. But let's say you wanted to become an engineer at the application level, I feel like, again, there, just find a problem to solve, just start tinkering around with it. You don't need a degree. You can kind of figure out what you want along the way.
mm. Yeah, when I was talking with the DataCamp CEO on our last podcast session, on the previous podcast session, he mentioned that these days, the degree is not necessary, but if you're trying to learn from like online sources, it is really hard to say whether this content is good quality or not. So people actually waste time searching for the content and may sometimes even get the wrong one. So this is interesting. Let's get our last few or maybe last question and we'll wrap this up. So for the product managers or program managers, what is the path that you recommend? Yeah, there was another question from project management transition to AI. How can one do that?
So I think even for product managers, the topics still remain the same. I am someone who has a heavy focus on the application layer itself. So really making yourself accustomed to what are the different usage paradigms in the generative AI space. But what product managers can skip is the implementation part. I would still ask folks to really use LLMs in their day-to-day life to kind of understand how they work. But you probably don't have to work around with those APIs or building frameworks. But in terms of topics, it would still remain the same, right? Like and just in terms of product management as a discipline, it wouldn't change with AI coming in. It's just that you'll have to translate these new problems to these new technologies that are coming up in AI, and in order to know that you can still stick to the application layer and kind of work around these different ways of using LLMs, as well as the challenges that come up with it. I personally, again, don't think there's a lot you should do in terms of just how product management as a field will change. Just augmenting the knowledge you have and the skills that you have as a product manager with these new AI technologies, and just a deeper understanding of them should be good enough. But I am no product manager. So again, take my advice also with, yeah, I don't want to give advice in spaces that I haven't closely worked with, but this is what I think.
Mm, great. So thank you so much for coming in and sharing. I truly enjoyed learning a lot about you and from you, and I hope to see more of your content on my feed. And if you guys haven't already, people that come from my network, check out the GitHub that Aishwarya built. It's amazing. I think it's the most comprehensive Gen AI repo that you can find so far, and I think it's like top trending something top six trending GitHub. That was so cool. Yeah. Was it?
Yeah, 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 at some point.
Still, I
Yeah, they
think
kind of release, yeah, these every day or every month or something like that. And at some point it was trending at 6. I was assuming, so that's kind of a widget that you can get from the website and put it on there. And I was assuming it'll auto sync, but I don't know if
uh,
it's auto syncing or if it's just, yeah.
uh, but either way, I when I first saw your repo, I'm like, oh my gosh, there's so much Thank you for compiling that. And we hope to see you more on Break into Data and Technical Founder podcast. Thank you for coming in today.
Awesome. Thank you for inviting me, Mary. This was really cool. Thanks everyone for joining.
Thank you, guys.